Hi everyone, welcome to this AWS Summit Online. My name is Eddie Calleja. I'm an engineer who works on the DeepRacer project. I want to take a second to say thank you to our exclusive AWS DeepRacer presentation partner, Accenture, running the largest private AWS DeepRacer League in the world. For more information, please go to www.accenture.com/AABG. So I briefly want to touch on the agenda that we're going to talk about here today. So some of you may be wondering, hey, what is AWS DeepRacer? And the answer to that is AWS DeepRacer is the absolute fastest way to get started with machine learning. And of course, we're going to dive a little bit deeper into that. And then I want to give you some of the tools that you need, some of the reinforcement learning tools that you need to really be successful with AWS DeepRacer. So we're going to touch on some high-level reinforcement learning concepts that you're going to immediately apply and learn more about within the AWS DeepRacer platform. And then we're sort of going to briefly go through the console, but in particular, how you talk about a reward function, which you're about to learn. And then we're going to talk a little bit about the architecture of how the nuts and bolts of the AWS DeepRacer for the device and the service work. So without further ado, let me first set the stage by giving you a little taste of the excitement that we have with AWS DeepRacer. So let's watch a short 30-second video that sort of goes through some of the highlights of what we've done over the past year and what we did at reInvent this year.
Welcome to the AWS DeepRacer League 2020 presented by Accenture. These are 1/18th scale RC cars that are fully autonomous thanks to reinforcement learning.
Cool. So that was just a taste of some of the action that we've seen, with AWS DeepRacer, people in the track training their models and really getting after it. So to answer the question of what is the AWS DeepRacer, it really breaks down into three components. The first is the actual physical device. And we wanted to bring machine learnings literally in your hands because there's just something so cool about actually grabbing something that really grabbing into that AI. So we released the original DeepRacer device at reInvent 2018. And on July 13th, we released the DeepRacer Evo, where we added 2 additional sensors. We gave the device the ability to perceive depth by adding a second camera, creating a stereo camera. And this works very much like your eyes. If you notice in the picture here on the left, you see there's actually 2 cameras in front. And again, similar to your eyes and how we perceive depth, that's exactly how the DeepRacer is going to learn to perceive depth as well. And then we also added a LiDAR. And this is so that the DeepRacer device no longer has to have horse blinders on. If you only have a camera and you can only see in front of you, you have no idea what's behind you or to your side. With a LiDAR, we can detect objects to the left of our field of view, to the right of our field of view, and behind our field of view. And this, as you're going to see in a second, this allows us to take on more challenging and complex problems. Now, of course, you don't need an AWS DeepRacer device to get started with AWS DeepRacer. You can go to the AWS DeepRacer console, and I hope that by the end of this talk, if you guys aren't doing so already, you'll be there, and get started in training your model. In fact, the model training all happens on the AWS DeepRacer console. And that's because if we actually tried to train the model on the DeepRacer device, it's going to be one heck of a workout for you guys. You're going to be chasing it all over the place. So the DeepRacer virtual environment is great for training your model, and it also is going to sort of drive home another point, which we're going to talk about in a few slides, which is the fact that you don't need massive data sets to train reinforcement learning models. And I find that completely amazing. And now some of you may be saying, well, you said the DeepRacer product breaks down into 3 parts and there's 4 logos here. And yes, that's absolutely correct. But you're going to see that these last 2 logos are actually really the same thing. When we were developing AWS DeepRacer, it was competitive. It was a competitive environment. It was something in my career I've never been a part of. People wanted to know who could train the best reinforcement learning model. And so we raced them against each other, and we raced them in time trials. So we initially just started off by saying, hey, you know what? Who has the fastest model? And that was in 2018, and well, actually in 2019, we released the DeepRacer League, and where people were training, where developers were now seeing who could bring the fastest models, because we really wanted to bring that to you guys, the customers. And this past re:Invent in 2019, we added community races because, as you're going to see in a second, the league runs on a monthly basis. And every month we release a new track, and it's a new competition. But you may want to host your own event and host your own competition with your buddies, and that's why we introduced community races. So the DeepRacer League in 2020, we added 3 new racing formats, which I'm going to talk about here in a second. So now we have time trial, object avoidance, and head-to-head. And we also have our online virtual circuit and our summit circuit, where you actually compete virtually in the summits. And this gives you a great opportunity to win prizes, because if you win in the DeepRacer League, it's not that you just, win the glory. No, there are actual prizes here. And so you have about 24 chances to win by our monthly competitions. And so I really look forward to seeing you guys getting out there and racing. Now, as I started off, I said, we added the DeepRacer Evo and we added these 2 sensors, LiDAR and stereo camera. Well, why did we do that? We did that, as I mentioned earlier, because we wanted to take on more complex environments. But the addition of stereo camera and LiDAR allowed us to unlock 2 new racing formats. So in 2018 and in 2019, when we launched the first league, it was just time trial. Your task was to train a reinforcement learning model that could complete the track as fast as possible. And that's still kind of true today. But we added some twist. We added object avoidance, where your task now is to complete the track as fast as possible, but try not to crash into these boxes we put in the track for you. And those positions change on a monthly basis, so no cheating. And then what we feel is kind of the ultimate test of who has the best reinforcement learning model is when you go head to head. In other words, if you train a model and I train a model, we can see who's fastest. But how does that model perform when we put them side by side and sort of head to head? So that's really the product right there. And so naturally the question arises, well, okay, what do I need to know to actually train one of these models? And that's what we're going to get into now. So sort of what we call reinforcement learning here for the Sunday driver. So sort of the basic reinforcement learning concepts that one needs to learn. And let's start off by taking a survey of artificial intelligence. And this means a lot of things to a lot of different people. Artificial intelligence really, if you played a chess game sometime in the early 90s, for example, like I did, some programmer actually coded up some strategies that allowed the machine to interact with you when you played chess. And that's artificial intelligence. And broadly speaking, it's sort of giving a machine some sort of human-like capabilities. But within the field, there's a subset called machine learning, which is really what this talk is going to focus about. And machine learning sort of has to do with building models through, mathematical algorithms that also give a machine, in many cases a computer, human-like behaviors. Like, for example, the ability to detect objects in a picture, which is something you and I may do. So within machine learning, there's broadly speaking 3 kinds of fields. There's the field of supervised learning, unsupervised learning, and then reinforcement learning. And let's just kind of compare and contrast some of the differences. And let me give you some examples of what each of these different fields within machine learning are really about. Well, the first one, supervised learning, this is the one that most people are familiar with, and it's probably the one that you come in contact with the most. And an example of a supervised learning model can be a object detector. So something that you give it a picture and it recognizes whether there's a cat or a dog in the picture. And facial recognition is another example of a supervised learning algorithm. And the most important thing to sort of call out here is that for supervised learning algorithms, we need to provide massive amounts of data to make them robust, and labeled data, which means that you have to take the pictures and somebody has to sit down and say, this picture has a cat, this picture has a dog, this picture doesn't contain any of them. And you need almost, you can need anywhere from megabytes to gigabytes of data depending on how accurate you want to make the thing. It turns out that a lot of machine learning algorithms are a bit data hungry. So it's kind of like one of the drawbacks of supervised learning, but it's been wildly successful. Then there's unsupervised learning. And here is a case where you have data and it's unlabeled, but you want the learning algorithm to learn the structure of the data. And so you still need lots and lots of data, but really the unsupervised learning algorithm is learning, like, for example, anomaly detection. So you may have come into contact, your credit card company, if it notices that you're in a different country, or at least mine does, sends me a text and locks my credit card, and then I got to call them and the whole thing. But that's quite possibly an unsupervised learning algorithm where it's kind of learned your behavior and your pattern, and it's seeing something that doesn't fit into that pattern, and then saying, hey, there's an anomaly here, we better flag this. And so both for supervised and unsupervised learning, if you look, I've used the word structure a lot. And that's really what those algorithms are doing. They're learning some sort of underlying structure. So some sort of underlying structure of what makes up a face, or what makes up a cat, or what makes up a dog. And then there's reinforcement learning, which is what we're going to be focusing on here for the next few slides. And reinforcement learning tackles this problem totally different. One, it doesn't require you to bring in large data sets. The virtual simulator environment, which you can access in the AWS DeepRacer console, is gonna basically provide that data for you. So we're gonna see here that the agent, which turns out to be the car, is gonna go around and collect data, and we're gonna label it by something called a reward function. And in a bit of a difference and a bit of a break from supervised and unsupervised learning, reinforcement learning is gonna incentivize the behavior. For example, learning how to drive, or learning how to navigate a track, or learning how to navigate a track with objects. And that's really the AWS DeepRacer problem. So one of the super cool things that I'm psyched about AWS DeepRacer is that we say it's the fastest way to get started with machine learning, in particular reinforcement learning, because we've identified a beachhead where we can onboard you with reinforcement learning without having to dive into a lot of the algorithms that kind of confound the learning process. So we've identified that beachhead to be the reward function. And what is the reward function? Think of a pet. If you have a dog, you want to reward that dog when it does something well. So when it does a trick, you give the dog a treat. Now when the dog, and that's positive reward. And now when the dog does something naughty, like this one over here, it seems to have torn up a bag or something, then you don't give it a reward. You withhold the reward because that's bad behavior. We don't want to incentivize the dog to have bad behavior. And if you do this enough time, for reasons that are beyond me, you end up with a lion. Now, I make no claims that reinforcement learning can turn your dog into a lion, but it'd be pretty cool if it could. But the idea is really like, hey, by giving you, by sort of using this concept of incentivizing behavior with reward, we can actually teach a machine learning model, in particular a reinforcement learning model, to learn a behavior, again, such as driving or driving around objects. So in order to really kind of dive into this a little bit deeper, we need to introduce some terminology. And as you're going to see, this terminology is going to show you that we scientists we're terribly creative people, and by that I mean we're not creative at all. So the first thing is the agent, and the agent in the AWS DeepRacer paradigm is just the car. But broadly speaking, in reinforcement learning, the agent is the thing that is making decisions, that's really being driven by the reinforcement learning model. So the agent is going to make decisions based on observations, which we're going to talk about here in a second, and those decisions are going to be based on the reinforcement learning model. Now, an agent interacts with an environment, and in this case, it's the track. But the environment is sort of where the agent lives, so where it moves around. So, our environment, maybe our office or backyard or something if we were reinforcement learning agents, which we are not. But for the car, the environment is the track. So we have the car as the agent, the environment's the track. And then from that environment, we observe the state. And the state is basically anything that we can observe. In the original DeepRacer product, that was just an image, because that's all we could see. An image was or state. With the DeepRacer Evo, you can actually now take in images and LiDAR data, or stacks of images if we want to measure depth, and that now becomes our state. So state is kind of interchangeable with an observable. It's the thing, the data that we are observing from the environment. And then there's the action. And the action is we take in a state. This goes to our agent, and the agent is driven by the reinforcement learning model. And sort of technically speaking, the reinforcement learning model, we often call it the policy. And again, we're very creative people. It's kind of a policy because it determines what action you're going to take. So we observe the state, and then we take an action. So in other words, an image comes in, and we can either speed up or go left or go right, or whatever action we've trained our model to do. And that action is determined by how we craft or reward. So in general, we want to construct and reward the agent for behaviors that sort of get it to our ultimate goal. And what is our ultimate goal? Well, our ultimate goal is to go around the track, and then to go around the track as fast as possible. So we need to think of ways to incentivize that behavior. And that sort of leads us to our final bit of nomenclature here, which is episode. And an episode means that is defined as when the agent starts, it moves around the track, and then it hits some sort of termination condition. Now, there are good termination conditions, which means you went one full lap around the track. That's good. That's exactly what we want. And then there are bad termination conditions, like you could have crashed, or you could have gone out of bounds before completing the track. And when we hit a termination condition, that is what we refer to as an episode. So how does this all kind of get put together? So I want to start with a simple example before we start talking about sort of like how we apply all of this to the DeepRacer. And so I want to take a very simple grid world example, which is what we have here. And each of these squares represents a state. So a state in this world is simply, box 1, box 2, box 3. Those are the individual states. And now the car has a very simple, what we call action space, because it can either go to the right, it can go up, or it can go down. Those are the only actions that we allow the car to take. And our job is to teach this car with the reward function how to drive the optimal path, which in this case is, as all of you are probably sitting at home watching, is just a straight line across there. So how do we do that? Well, we craft a reward function in such a way that we give it high reward for it getting on the straight line, and we give it not as great reward for it sort of not getting off that straight line path. So you can imagine in the grid world, which is what we call this, right? Because it's just a bunch of grids and each state is a grid. This is pretty simple because we can actually assign a reward value for every little box in here. And in fact, when we craft the reward function, we don't actually, it's actually really a function. It's going to take in some information from the environment. In this case, it's probably going to simply just take in the XY coordinate of the box, and then it's going to assign it a reward. The agent itself has to do some amount of exploration on the grid to determine where it picks up that reward, so that it sort of crafts the RL model or policy that's driving it. So if you see here, we can see an example of the agent sort of exploring around and, kind of wondering a bit, and it really should be random at the beginning. We call this exploration. And it really is, again, we're just very creative in the reinforcement learning community. It really is what it sounds like, which is that it starts to explore. It starts looking at different paths that it could take, and sort of it starts to score it. So the technical term there is it fills out a value function, and that again also is exactly what it sounds like, which is how valuable am I in this state, and I want to take an action that takes me to a more valuable state. But we can't explore forever, as it turns out. If we explore forever, we never find that straight line sort of path, which is what we really want here. So at some point, we need to start looking at our policy and saying, hey, our policy or model, depending on how you want to call it, and saying, hey, is it like, have we learned anything? And I'm going to talk more about that here in just a second, which is getting into this exploration exploitation. So when we're doing exploration, we're taking random actions around our environment. We're visiting random states, and we're computing what the reward is here. And particularly, we want to kind of maximize long-term reward, so we kind of see assign a value to each individual state of how good the reward is. And then after some time, and then after we do that, we hit a terminal state, and then we improve the model or policy. And then we do this many times. But after some period of time, we actually want to take the knowledge that the model has learned and exploit it and use it so that we can get on to that better path. And you kind of saw in the slide before how the model kind of zigzags up, and then eventually it starts converging into that path because we're doing less and less exploration and more exploitation, which is sort of what these two slides are about. And really, this is one of the critical problems in reinforcement learning. So you have to sort of craft your reward function so that you incentivize the behavior you want, and you have to have the right amount of exploration and exploitation. So sort of recap or simple example, we took a grid world. We wrote out a reward function, which we could write because the grid world is very tiny. We could figure out each individual grid just with some XY coordinates. And then we actually used reinforcement learning with that reward function to learn a model or policy, same thing in this context, that could drive in a straight line across. And that's just the power of it. And we're going to see, we're going to just do this for the DeepRacer as well. Now, the DeepRacer problem is a bit more complicated because there's not a grid of states that you could do. There's lots of different paths that you could take around the track, and the car has sort of a lot of exploration that it can do. And this slide right here really kind of encapsulates what I was trying to drive at here. So basically, the agent moves around the environment. It takes an action, and it goes from one state to another. And when it goes to that state at t+1, here t just refers to time, and time is discretized. So, time t equals 0, 1, 2, 3, 4. It's, whatever those intervals are. And basically, it scores a reward. So every action takes you to another state, and we determine using the reward function, which is crafted by you guys, how good an action that was. And this is exactly how we incentivize the behavior, because we do this over the course of an episode. We basically take an action, end up at a state, figure out if it's a good reward, and then from the next state, we take another action, and et cetera, et cetera, et cetera. We collect all that experience, and then we go and we use a reinforcement learning algorithm to craft a new model or policy, and then we continue to improve on it. And this is very similar to really all of machine learning, where there's this flywheel effect of, you train a model and then you improve on that model on every iteration. Well, hopefully you're improving on that model on every iteration. So, as I mentioned just a second ago, the DeepRacer problem is a bit more complicated. So unfortunately, our grid world sort of labeling everything example is not going to work. So we need to do something that's a little bit more complex. And that's, we need to take the policy or model and approximate it with an artificial neural network. Now, if you don't know what a neural network is, you can just consider it as a network of nonlinear functions. And that's really all it is. And you don't need to know any more than that to use it. And the reason we want to use an artificial neural network is because we're sort of getting this state coming in, and these decisions can be complex, and they also need to sort of generalize. And it turns out neural networks are a really good choice for solving that kind of problem. Now, for those of you familiar with how you train neural networks, you sort of know that you use gradient descent, and in the case of reinforcement learning, we use gradient ascent. And the reason for that is just that it's easier to formulate the problem in terms of maximizing long-term reward. So we sort of want, the way we're going to craft these reward functions is that we want the agent to attain the highest reward possible. So in other words, you make a series of actions that takes you to particular states that accumulates reward, and the algorithm is such that it's going to maximize that reward. So it's going to find the set of parameters that we use in these neural networks that optimizes or maximizes the reward. And you can just see sort of just how critical the reward function is in all of this. So, you guys actually now have the tools, the concepts in place to go off and write your own reward functions. So I want to quickly turn it to looking at some of the infrastructure of this, because after all, we are AWS. A lot of us are developers. So you may be wondering, well, what happens when you hit go on the virtual simulator, when you go to the AWS DeepRacer console and hey, train a model? Well, what happens? Well, this is the architecture. We are built on top of AWS DeepRacer and AWS RoboMaker. And the virtual environment runs on AWS RoboMaker, which is AWS's platform for robotics, and also for using the robotic simulations. It's built on top of Gazebo. And the training algorithm runs on AWS's one-stop machine learning platform, AWS SageMaker. And so basically, we set up behind the scenes in our service account, we set up these two jobs, and we have them communicating via an S3 bucket. And then we stream all the data from the virtual environment and from the training environment and from the training algorithm out to CloudWatch, so you could see what's going on. And we also use Amazon Kinesis Video because here, you want to take a look at what your model is doing. Is it learning to drive? So that's going to be the video that you see there. That runs completely on KVS when you go to the AWS DeepRacer console. Now, once you've trained your model, and I should also mention that the instances that we used on RoboMaker and SageMaker are the Intel Skylake microarchitecture. And we do that because it has terrific performance for running and training these models while optimizing for cost as well. So after you train your model, then what you do is you take that model and then you deploy it onto the device. And we'll talk about that in just a second. So how are you going to craft your reward functions? Well, when you go to the AWS DeepRacer console, you're going to go and create your model, and you're going to walk through the wizard that does that. And eventually you're going to end up at a screen that looks like the one I'm showing here. And this is where you're going to write a bit of Python code. It's Python 3 syntax using the parameters that we give you. And there's some on the right tab, you can click for help to see what each one of them means. And at the end, of this talk, I'll also point you guys into some great resources that you can visit so you can continue to expand your knowledge beyond this workshop. But you're going to end up here at this very simple IDE thing that we've set up for you. So you can craft your reward function, determine what kind of behavior you want to do. You can start with one of our 3 example reward functions. Most people start with the center line reward function. And really, all we're doing in that reward function is incentivizing the car to stay near the center line. So we give it some penalty when it's far away. And I strongly urge you guys to hop on the AWS DeepRacer console and take a look at that reward function. It's a great place to start and gain more intuition into this. So then we actually provide a little bit of validation so that you don't end up crafting a reward function that isn't going to work. And we actually use AWS Lambda, which is another great AWS technology to do the validation. So that is how you can go. That's sort of our architecture, and that's how you can go to the AWS DeepRacer console today and get started with machine learning. And it's absolutely the fastest way to get started with machine learning. So I talked about the DeepRacer Evo. It became generally available on July 13th. It's now available for purchase on Amazon.com. So what is under the hood of the AWS DeepRacer device? And these are just some specs for folks to take a look at. So what we have here is we take the input data and we have the model that you guys train. So that model gets pulled down from the simulator or the AWS DeepRacer console. And when it goes onto the device, we optimize it using OpenVINO. And this is how we get that lightning fast inference required to actually have the thing drive. Because if it went too slow, we would probably just be crashing into a wall most of the time. So OpenVINO, so you take the input in the car through the camera. It goes to the OpenVINO optimized model. It takes an action, and that's it. You're off into the races at that point once it gets on there. So that's it. So you guys are ready. You guys are ready to take this and start your reinforcement learning journey. And I hope to see you out there. And my favorite part of this talk is when I can say, developers, start your engines. I want to see you guys on the leaderboard, and I'm looking forward to it. And I want to mention some additional resources available for you. The Slack community is an absolutely fantastic place to learn and engage with people that are doing well on the leaderboard. And you know what's so cool about this product is that we see everybody going on this learning journey through reinforcement learning. And a lot of that is really driven by you guys, the community, and the sharing that goes on there, and just all the great stuff there. We have a GitHub for some of the exercises we would normally, which we do on the workshops. They're great to go through. They're fantastic. They'll get you started with reinforcement learning. We have a free course, of course, at the link here on the screen. We have tips. We have the forums. And you know, if you're interested more in Intel OpenVINO, here's a link down here where you can learn more about that and how you can do fast inference. There's also AWS training as well, and I'll put the link right here so you can get more into machine learning that way.